when the object changes its position with time, when we see the object moving, we say that the object is in motion. So first of all, let's see the definition of motion. Motion, an object is said to be in motion when its position changes with respect to time. For example, if I say that a car is moving on a road, then car is said to be in motion because car is changing its position with time. Now, there are two ways, directly perceivable and indirectly perceivable motions. Directly perceivable motions are those which can be perceived directly, which can be observed, which can be seen. For example, if I say that car is moving on a road, then we can see the car moving on the road. We can see the car changing its position. So this is an example of directly perceivable motion. Second is indirectly perceivable motion. Indirectly perceivable motions are those which cannot be seen. For example, motion of the air. We can feel the air moving, but we cannot see the air moving, right? So this is an example of indirectly perceivable motion. In our previous classes, we have read about various kinds of motion, right? So the first one is rectilinear motion. So rectilinear motion is the motion of an object along a straight line. You can look at the picture. There are three examples. First is a car moving on a straight road. So this is an example of rectilinear motion because it is moving in a straight line. Second, an aeroplane is flying in the sky. This is again an example of rectilinear motion. Third, a freely falling object. In this case, the object is falling freely under the gravitational force of Earth. So this is also an example of rectilinear motion. Second one is circular motion and rotational motion. Okay. Now first one is circular motion here. You can see the object here. It is moving along the circumference of the circle. So we can see here that this object is moving about a fixed point, and this fixed point is the center of the circle, and this object is at a fixed distance from this fixed point. So, okay, so when an object moves along the circumference of the circle, when an object moves about a fixed point, we say that the object is executing circular motion. And one more thing to be noted here, that this fixed point is lying outside the object. Okay, here I have written cm. This cm means center of mass. So center of mass, you can see here, center of mass is the point at which the entire mass of the object is supposed to be concentrated. Okay, and for symmetrical objects like sphere, cylinder, center of mass lies at the geometrical center of the object. For example, in case of a sphere, it lies at the center of the sphere. Okay, so we can see here that the center of mass of the object is moving about a point, about a fixed point called center of the circle. Okay. Second is rotational motion. Here we can see we have taken an inclined plane here. We can see a cylinder rolling down an inclined plane. So this cylinder is rolling down an inclined plane. It is moving about its own center of mass. Okay? The rotational motion of the object is the motion of the object about its center of mass. So in this case, it is moving about a point which lies inside the body, inside the object. So the point about which the object is moving is lying inside its body. It is moving about its own center of mass. It is moving about the center of the cylinder. Okay. So in rotational motion, object moves about its center of mass, while in circular motion, we can see here that the center of mass of the object moves about a fixed point which lies outside the object. And here in rotational motion, object moves about a point which lies inside the object. So this is the main difference between circular and rotational motion. A third type is oscillatory and vibratory motion. So oscillatory motion is the to and fro movement of the body about its mean position. So mean position is the fixed position. It is the fixed point about which the object oscillates. Mean position to extreme position. extreme position, mean position to extreme position. So maximum displacement, this is the amplitude. Amplitude, the displacement, distance covered by the object executing oscillatory motion. Now second is here we can say that in this example is simple pendulum. So movement of simple pendulum is the example of oscillatory motion. Second is vibratory motion. So vibratory motion can be in all directions. And one more thing I want to add here, that we can relate oscillatory and vibratory motion. So vibratory motion can also be considered as oscillatory motion of very small amplitude. So if the amplitude is negligibly small, if the amplitude is very small, we can say that the object is executing vibrations. Next point here is that motion is a relative term. First, we should understand the meaning of the word relative. Here, because we are talking about motion and motion is relative, so we are talking about the relative positions of the observer and the object under study. Okay, so things would be more clear by taking the examples. Let's take an example first. Here is the picture. You can see, look at the picture. There are three observers, observer 1, observer 2, and observer 3. So we can see that observer 1 is standing on the floor, he is at rest, and observer 2 and observer 3, they are sitting in the train, and this train is moving in forward direction. Okay, so let's go back to observer 1 now. Because observer 1 is at rest, he is not moving, so for him trees are at rest because his distance from the trees is constant. His distance from the trees is not changing. So for him, trees are at rest. And observer 1 sees the train moving in forward direction. Okay? Because observer 2 and observer 3, they are sitting in the train. So for observer 1, observer 2 and observer 3, they are also moving in forward direction along with the train. Okay? Now let's come to observer 2. For observer 2, he is in the train and train is moving in forward direction. So for him, observer 1 and trees appear to be moving in backward direction. For him, trees and observer 1, they are moving in backward direction. And observer 3, who is sitting next to him in the same compartment, because his distance from observer 3 is constant, because his distance from observer 3 is not changing, so for him observer 3 is at rest. Okay, so for observer 2, observer 1 and trees are moving in backward direction while observer 3 is at rest. Okay, now observer 3. For observer 3, again observer 1 and trees are moving in backward direction because he is moving in forward direction. He is in the train and train is moving in forward direction. So for observer 3, observer 1 and trees are moving in backward direction while observer 2 is at rest because distance of observer 3 and observer 2 is constant. His distance from observer 2 is not changing, so he is at rest. Let's take one more example. Here we can see a book lying on the table and there are two observers, observer 1 and observer 2. So observer 1 is observing the book lying on the table and he finds the book at rest. He finds the book not moving, okay, because his distance from the book is not changing, all right? And there is an observer 2 who is on the moon, on the surface of the moon, and observer 2 is observing the same book, okay? And for him, book is not at rest. Why? Because as we know that Earth rotates about its axis, okay? And moon revolves around the Earth. So the relative position of the observer 2, which is on the moon, and the book is changing, keeps on changing, and because of this, because distance is changing, so for observer 2, book is moving, while for observer 1, book is at rest. So the same book which is on the table, for observer 1, it is at rest, and for observer 2, it is moving. All right. So from this we conclude that motion is a combined property of an object under study and the observer. Object under study, in the second example, object under study was the book which was on the table, and observer, observer 1 and observer 2. So it is the combined property of both object under study and the observer who is observing the object. Second is that nothing is in absolute rest or in absolute motion. Okay. So here we talk about relativity. Motion is a relative term. We cannot say that the object is absolutely at rest or it is absolutely in motion. Okay. Next point is reference frame. Now, before defining the reference point, I would like to explain it through example. Here we can see a car moving on the road. There are two observers, observer 1 and observer 2, who are observing the car. Okay. And these two observers, observer 1 and observer 2, they are standing on the opposite sides of the road and they are facing the car. Okay, they are observing the car. Now for observer 1, car is moving towards right. Car is moving in right direction. While for observer 2, car is moving in left direction. Okay, the same car for one observer is moving in right direction and for second observer it is moving in left direction. So reference point is a fixed point or a fixed object with respect to which a given object changes its position. Fixed point or a fixed object. So we fixed an object, we fixed a point, and we call that as reference point, and with respect to which the given object changes its position. Let's take one more example. So here we have taken railway station as reference point. Okay. And from railway station, this school is 2 kilometers north of railway station. Okay, so any reference point can be chosen as per our convenience. You can choose your home as your reference point. You can choose your school as your reference point and measure the distance of other places from that reference point. So reference point can be chosen as per our convenience. Let's go back to definition again. It is a fixed point or fixed object with respect to which a given object changes its position. So that fixed point, that fixed object is the reference point. You can choose yourself as reference point. So reference point can be anything. Anything can be chosen as per our convenience. All right. So as we had taken, in this example, we had taken railway station as reference point. Our next point is point object. So if the size of the object is smaller than the distance covered by the object, we call the object as point object. For example, a car is moving on the road. It's quite obvious that size of the car is very, very smaller than the distance covered by the car. So car is called as a point object. Now, what is the concept behind it? We know that a line is made up of infinite number of points. All right. A cylinder is made up of infinite number of rings. When infinite number of rings are joined together, stack is formed, and that stack is a cylinder. And when infinite number of points are joined together, a line is formed. Okay, so a car is a solid object. So it is made up of infinite number of points. It is made up of infinite number of particles. And when a car moves on the road, suppose here we have taken a car which is moving with a speed of 40 kilometers per hour on the road. So we can see that every point, if I choose I had chosen here point A and point B. All right, you can see in the picture point A and point B. So when car is moving with a speed of 40 kilometers per hour, then every point, each and every point on the car is moving with the same speed of 40 kilometers per hour. So point A and point B both are moving with the speed of 40 kilometers per hour. So car as a whole can be taken as a point object. I hope the things are clear. So that's all for today. Thank you.